Okay, what's the technique to do this one?
You find the whole part and the small part and you minus.
Yep, okay. So that will be area rectangle. Area rectangle plus area of the triangle.
Yeah.
Right? Yeah, or the triangle, and then minus the area of the tiny rectangle.
Yeah.
Okay? Alright? So the main rectangle is, what's the area of the main rectangle?
The big one.
Yeah?
6 times 3.
6 times no.
6 times 4.
Yep, and then the area of the triangle?
It's 4 times 4 times half.
Sorry?
4 times 4 times half.
Yes, it's half of 4 times 4. And area of the tiny rectangle?
That's 1 times 2.
1 times 2. That's right. Work it out and you'll be done.
Okay.
Okay? Easy enough. Moving on. Question 2. Find the area of each of the shapes here. Okay. So find the area of each of these. What's the area for question A?
I have to find triangle first, right?
No.
Just the whole thing?
What shape is that?
Parallelogram.
Correct. What's the area of a parallelogram? Remember, is the idea that you take this triangle and then you move it over here, it becomes a
rectangle.
Yep, so the area is?
The area is just length times height.
Correct. Is length times height, or just the base times the height.
Yeah.
For that one. Okay? How about B?
It's just 48 meters for that?
Yep.
Okay.
And then B? What shape is this?
It's a rhombus.
Yeah. No, hang on. No, it's not a rhombus.
Trapezium.
Trapezium, yes. Okay, what's the area of trapezium?
Base times height.
What base though? There are 2 bases.
9.
Just this one base? No. You sure you did revision?
Yeah.
What's the area of a trapezium?
Base times height.
There are 2 bases, so what do you do with them? What do you think? It's sum, so it's half times the sum of bases. Okay, half times the sum of bases times by the height.
Okay.
Make sense?
Yeah.
Yeah. Remember the idea is that we chop that in half, right? We initially chop this one in half and then we'll take
Yeah.
Yeah, remember that? We were doing that chopping thing, and it turns out that it will be half, and then you have to add the 2 bases in order to make the rectangle.
Yeah.
Right? But when you times it by the height, it's double the area, so you have to half it.
Yeah.
Okay?
So 45 half times 45.
How'd you get 45?
Half times 14 times 4.
Yep, that's right. Okay, I'm not going to write it in here, so you have to go back and redo these questions. Question C, what's the area? What shape is that?
That's a parallelogram.
No.
Hey, that's a trapezium.
No. Trapezium is when you have...
Isn't it just a diamond?
What's the name? Start with R.
Rhombus.
It's a rhombus. Yes, because what's a rhombus? What's the shape, like the type of the side for the rhombus?
They're all the same.
Yep, they're all the same. Okay, so this is a rhombus. Alright, so I'll write this one as a parallelogram, and this one is a trapezium. Alright, and this is a rhombus. Okay, what's the area of a rhombus?
We should find each part first.
What part? No. You're talking about the small ones? No, you don't need to. Remember this? We drew this before?
Oh yeah. And then it's like, wait, hold up. It's just half. Oh, it's half times. No, it's just base times height, and you divide by half, right?
Yes, but what are you talking about as a base? What base here?
Oh, it's just length, right?
It's half times the two diagonals,
Oh, okay.
right? It's half times xy. Remember, it's not base times height because a rhombus is a parallelogram. Okay, technically, but you have to call it a rhombus because it has a special form of a parallelogram. Now, if you take the base, which is, let's say, that one there, that's the base, and then you somehow get the value of the height here, when you times base times height, that's it. That's the area. You don't have to half it,
Okay.
right? Because remember, the parallelogram is a rectangle that's shifted over,
Yeah.
right? So that's why it's just similar to this one, base times height. But if you're not given the base and the height, but you're given the diagonals, so you see, this one is the two diagonals. If you're given the two diagonals, then when you multiply them, you get a bigger rectangle.
Yeah.
Does it make sense? And then you have to half that.
Yeah.
Okay? How about question D? What's the area then?
Wait, so x times y is just 6 times 8, right?
No, not 6 times 8.
Isn't it just the two diagonals?
Yeah, but is 6 the diagonal?
Oh, is it the whole thing?
Yes.
So 12
Yep.
times half times 12 times 16.
Yes, that's right. Okay, now question D.
Okay.
What's the area? What's the shape of this one?
Kite.
Kite, yes. Area?
Hold up.
What shape do you think this is similar to?
Trapezium?
No.
Rectangle?
No.
Triangle.
The shape, the way to do this one is similar to a rhombus. If I were to draw this, what do you think the area is?
What do you mean?
This diagonal is the width of the rectangle.
Okay.
This diagonal is the height of the rectangle, right? Or the length of the rectangle.
Yeah.
Okay? So if I do x times y, so if I multiply the diagonal, the two diagonals, what do I have to do to get the actual kite area?
Divide by half.
Yes. Well, divided by 2 or times a half, one or the other. Okay? Because divide by a half is like this. That's not right.
Okay.
Okay, so divide it by 2.
Okay.
Okay? Make sense? So it's the same as a rhombus.
Yeah.
It's the same idea where you times the two diagonals, you get a bigger rectangle.
So is it 8 times 4?
It's 8 times 4, yes. Half of 8 times 4.
Okay.
Okay?
Yeah.
Alright, I'm not going to go through that. You have to go back and do these questions. So you have a textbook, right?
Yeah.
When you do these, you should get a textbook so it's clean. I don't use my notes. Only refer to my notes if you forgot how to do it.
Okay.
Okay, you need to use the textbook and see if you can get the right answer.
Okay.
Okay, so that's question 2. Moving on, question 3. What's the volume of a fish tank with those three dimensions? What's the volume?
It's just a rectangle, right? So it's 90 times 45 times 60.
Yeah, correct. It's just base times height times it's just length times width times the height. Okay,
Yeah.
Not too bad. Make sure you multiply them and get the answer and check the answer. Now, volume of each of these prisms. What's the general idea for volume of a prism?
It's just length times width times height.
Not for these ones. Because like these ones, what's the surface area of the prism? It's not exactly a rectangle. Like question A here.
Yeah. Oh, so that's half. Length times width times width times height times half, right?
No. These special prisms, the volume is equals to the cross-sectional surface area times by the height.
Okay.
Okay, so CSA is a cross-sectional area. What's the cross-sectional area?
The area over the whole thing?
Not the whole thing. Of when you slice it, when you make a slice out of it. Alright, what's the shape of the cross-section?
Okay.
What's this one?
35 millimeters.
No. This one's a triangle. What's the area of a triangle?
Of that. 16.5, right?
35, 17.5. So it's half times 5 times 7.
Okay.
right? And that's the area. And then you need to times it by the height, which is 10.
Okay.
Does that make sense? So this is the cross-sectional area of this shape, which is a triangle. So you see these prisms have different shapes.
But isn't it short? I did 10 times 7 times 5 times half.
Yeah, it is, yeah. So if you actually work it out, it will be, I would do 10 times a half, which is 5, and then times by 5, which is 25, and then times by 7. So I don't get decimal number.
Okay.
Okay, so you can actually, if you get to this formula, you can actually just work it out like so. So half times, you rearrange it, so times 5, 10 first, and then 5 and 7. So that'll be 5 by 5 by 7, 25 by 7, which is 140, right? And then plus 35, which is 175. Right, make sense?
Yeah.
Yeah. So yeah, that's how you work through like a multiplication by.
Wait, what if you do it just 10 times 7 times 5?
That would give you 350, and you divide by 2 is 175. Same thing.
Okay.
Okay, so you can do it in any other way, in either way, as long as they're all multiplication, then you can do it in any order.
Okay.
The answer should still be the same. Okay, now for question B, what's the cross-sectional area? What's the shape of the cross-sectional area?
3 times 8 times 6.
Well, answer my question first. What's the
Parallelogram.
shape of the cross-sectional area?
Parallelogram.
That's right. What's the area of a parallelogram?
It's just length times height.
Yep, that's right. So yes, this volume is 3 by 6 and then by 8.
Yeah.
Okay. Now, how about question C? What's the cross-sectional area?
That's trapezium, right?
Trapezium. Very good. And what's the area?
12 times. Is it 12 times 5?
No.
12 times 6, right?
No. What's the formula for trapezium area?
Oh yeah, half of the sum of the bases.
Yep.
Okay, so 2 bases are 7, 6.
No. The two bases are the lines that are parallel to each other.
So 7 and 12.
7 and 12, yes. So it will be half of
7 times 12.
no 7 plus 12, sum of the two bases, and then
times height.
which is
6.
that's right. Okay, and then the volume would just be the cross-sectional area times by the height, times by the height of the shape. And what is it?
It's 6.
No, you have to see it a little bit differently. Times by how much it is extruded, and the answer is 5. So if this is the surface area, right, the height of it is the one that's perpendicular.
Yeah.
Okay, make sense? In this case, the height here is 10, right, because it's perpendicular to the surface area
Yeah.
of the cross-sectional area, right? And then this height here is 8.
Okay.
Does that make sense?
Yeah.
Where the cross-sectional area is the parallelogram here.
Okay.
Did you learn this at school? The cross-sectional area formula?
No.
Okay, well, just gonna have to learn it now.
Okay.
Okay, so for these prisms, just find the cross-sectional area, which is the blue stuff, and times it by the perpendicular height.
Okay.
Right, so that's a little bit different from the normal height. Okay, question D. What's the cross-sectional area?
Is that a rhombus?
It is a rhombus. That's right. What's the formula for the area of the rhombus? In this case,
The diagonals. So hold on. 4 and 2. Height times 2 times 4.
sorry,
Height times 2 times 4.
for the volume.
No, for the cross-sectional area.
No, the cross-sectional area is half times xy. Remember, for the rhombus, it's half xy, yeah, and x and y is the diagonals. Because remember, when you times the two diagonals,
Wait, so what's h then?
sorry,
What's h?
what do you mean by h?
Height, is that height?
Oh, height is the perpendicular height. The perpendicular height is the height of the shape, the line that is perpendicular to the surface area.
Well, you said it was the 2 diagonals.
Yeah, two diagonals, yes. So the two diagonals is this diagonal here and then that diagonal there.
What's the h for?
Wait, hang on. This is the number 4, yeah?
Yeah. Oh, I thought it was a H.
Sorry, it's 4 because it's 4 times 2.
Okay.
Yeah, so this is 2 diagonals, right? So the area is half times xy.
Okay.
Okay,
Yeah.
and y half.
Y is 2, right?
Yeah. But wait. Why do we need to times it by half or divide it by 2? Why?
Because I don't know.
I explained that 2 times already. When you times the 2 diagonals, you get a what shape?
A rectangle.
A rectangle, and
this is half rectangle.
this is half of that rectangle. You see, if you draw a rectangle, it's twice as big.
Yeah.
Right? So you need to half it to get the area of the rhombus.
Yeah.
Make sense?
Yeah.
Okay. Right. Moving on. Yeah. So that's cross-sectional area. That's not the whole. Yeah. So the volume which would be the cross-sectional area times what's the perpendicular height?
That's 9, right?
That's 9. Yes. Okay. Now last one. What shape is this?
That's a no, kite. It's a kite.
It's a kite shape. Yes, it's a kite shape. So what's the area of a kite? What is it similar to?
Similar to trapezium. No, a rhombus.
Rhombus. So
if you find the 2 diagonals,
which are?
wait, I think the top or the bottom
Which ones?
are the diagonals.
So the 25, right? If you look at 25, it's going from here to here, and then it marks that and that.
Okay, so 30 as well.
Hi?
25 and 30.
No.
Just 25.
25 is one diagonal. What's the other diagonal?
Yeah, isn't it 30?
No.
10.
It is 10 because. See that?
Oh yeah.
Yeah? Like, if you want me to draw it more, I will draw it. I will make a little. See? That's a rectangle, right?
Yeah.
If one side is 10, the other side must be 10, right? And the other side is the diagonal.
Okay.
Okay?
Yeah.
Same with 25, right? This is 25. So if I were to draw if I draw a rectangle here, 25 is this side and the other side is the diagonal.
Okay.
Also 25.
Yeah.
Make sense?
Yeah.
Remember, when you go back home and retry this one, you can't look at my answer first, yeah? You have to see if you can do it without looking at the answer.
Okay.
So it will be these ones, right?
Yeah.
And then the volume would be the cross-sectional area times by what's the perpendicular height?
30.
30, that's right. Make sense?
Yeah.
Okay? Alright, so don't know how much revision you have done, Mustafa, but I expected you to be able to answer a lot more of my questions. Okay? Which means that I don't think you are ready for your exam yet. You better go back home and redo these questions.
Okay.
Okay? Otherwise, I'm really worried about your exam tomorrow. So, question 5. What are the exact volumes of the cylinders with the following measurements? So, radius. You've learned about cylinders, right?
Yeah.
Okay. Volumes of cylinders with the following measurements. Radius 5, height is 4. What's the volume of a cylinder?
Radius. If radius is double the diameter, right? Radius is double the diameter, right?
No, you said the opposite.
Diameter is double the radius.
Yes.
Okay.
What's the volume for a cylinder? This is a special type of prism, so it's also cross-sectional area times perpendicular height. Okay. But what's the cross-sectional area?
The radius?
Has something to do with the radius, yes?
Oh, pi r squared?
Pi r squared times h, that's right.
Yeah, okay.
That makes sense? Because pi r squared is the area of the circle, right?
Okay.
And then times by the perpendicular height. Alright, so question A would be?
Let's see. 3.1. Can we see like approximate value?
No. They said exact volume, so you need to just go, you just have to use pi.
Yeah, okay.
It'll be like that.
Yeah.
Okay, and then B?
Yeah, pi times 6. Wait, pi times...
The diameter is 6.
Yeah, just 6. So The radius is half, right? 3 squared times 7.
Yes, that's right. Make sense?
Yeah.
Okay, so that's question 5.
I think I did it a little bit differently in school.
Oh, how?
I think I did like yesterday by myself.
It's definitely pi r squared times h. If it's diameter, it would just be pi times diameter over 2 and then square that times h.
Oh, never mind. This is like circumference.
Yeah, circumference, that's different. That's 2 pi r. That's surface area.
Yeah.
I think we're getting to that in a sec. Okay, alright. How are we going for time? 20 minutes. Okay, good. We still got time. Question 6. Find the surface area of each prism. How do we find the surface area of these prisms? For example, the first one for question A here.
Our teacher makes like draw the whole net and do it.
That's right. Draw the whole net and do it.
Okay.
Okay. Or for me, I see it this way. For this prism, right, I see that the back and the front is the same, right?
Yeah.
Yeah. And then the top side here is that's a separate one, and then the back side is another separate one, and then the bottom is also a separate one.
Aren't they the same? The top sides?
No, it's not the same. Because if you were to, okay, I guess this is why your teacher most likely have you guys redraw the net. That's 25, that's 15, and this side is 20, right?
Yeah.
Okay. If you draw this one, it will be 15 by, the length is 10, right? And then this one will be 25 by 10, and this one is 20 by 10. It's all different.
Okay.
Does that make sense?
Yeah.
Because these rectangles, each of them has one side on the triangle, and each side of the triangle is different. It's 20, 15, and 25.
Okay.
That make sense?
Yeah.
Yeah. So you need to calculate the two triangles. They're the same, but then the three sides will be different.
Okay.
Okay. How about question B?
So that one right there, the space right there, so 15.
Mm-hmm.
And the big sides 32 both of them.
Yep, that's right. And then?
And
What other
the
side?
bottom side and the top side is 24.
Yeah, good. And times 2.
Yeah.
Right? Okay, good. So you're okay with question B.
Wait,
How
what
about
do you mean times 2?
Because it will be 24 top and 24 bottom.
Yeah, I said that.
Yeah.
I
So
said both, yeah.
oh yeah, then both of them, yeah. So 24 each, and yeah, and you add them up. Okay, good. And now question C. What's the surface area of question C?
What is that, rhombus?
Mm-hmm.
Okay, so six no wait. I have to find the diagonals, right?
You do have the diagonals.
6 and 8.
Yes.
So half times 6 times 8.
Yep.
24.
Yep. And then you have to times it by 2, right? Because the front and the back faces are the same.
Oh yeah. So
Okay.
48.
Yep. And
then top and the bottom.
Yep.
That's 9 and 8.
Not quite. 8 is a diagonal.
Is it 9 and 5?
Yes, it's 9 and 5. So this is a bit tricky. They put the 5 here because this is the prism, right? That means that side is the same as this, the same as that, the same as this, and also the same as every single side at the front. Does that make sense?
Yeah.
Yeah. So that's why 5 here also means it's 5 here, and every single side of the rhombus is also 5. That's why it's a rhombus.
Okay.
Okay. So that would be 9 by 5, and so that's top and bottom. How about the two sides?
Where?
The two sides. This one.
Oh, 8 and 5.
No.
6 and 5.
It's also 9 and 5. Remember, 8 and 6 is only the diagonal.
Oh, okay.
Okay? So if I were to redraw this shape without the diagonal measurements, it will look something like this. It will have to be somewhat of a rhombus there. Alright, and then I draw this shape here. Okay?
Yeah.
So then this side would be 5, which means that's 5 here, 5 here, 5 here, 5 here. And then the perpendicular height is 9, 9, and 9.
Okay.
Does that make sense?
Yeah.
So be very careful. You're seeing the diagonals as a side. That's not the same, yeah? Look at this. You have to watch out. You have to look at what these arrows are pointing to. It's pointing to these lines. And you have to look at these lines, right? And then see that these lines go to this point here, see? And then this one goes to that point there, right?
Yeah.
So it's saying that the distance between those 2 points is 8. And the distance between those 2 points is this diagonal here, right? So in a clean version, it will be this diagonal here. Does it make sense?
Yeah.
So that diagonal is 8, right? They don't want to write like a messy 8 in there. So that's why they draw like the dotted line there. But remember, this is the diagonal. Same with 6 there, you see? It's from that point to that point, aka it's a diagonal of that shape there.
Okay.
Yeah, it's not the perpendicular height.
Yeah.
Okay, so you have to watch out for these ones. So worried you'll make these mistakes tomorrow. Okay, watch out for those ones. And then question D, what's a cross-sectional area? Sorry, what's the total area? What kind of shape does this consist of?
That's a prism. No,
It's a prism, yes?
A triangle prism, isn't it?
Yeah, triangular prism, yes.
Okay, so the side right there. 5 times 12.
Yep.
Times half.
Yep. Right, that's a triangle, and there are 2 of them.
It's 5 times 12.
Yeah.
You wrote 10.
Sorry, yeah, 5 times 12. Yeah. Yep. Okay.
Okay, so 30, and then
there are 2 of those, which would make it back to 60.
oh yeah, okay.
Alright.
And then this side on the right, 10 times 5. Plus no, that's it. Yeah, just 10 times 5. And then the bottom side, the bottom is 12 times 10.
Yep.
And then the big side there is that's 12 times 10, right?
No. You mean you're talking about this big one, right?
Yeah.
That's not 12 times 10.
It's 12 times
That's not 12.
10? 10 times 13.
It's 10 times 13. So I'll rewrite it a little bit. So if you notice, right, the 3 sides, this one, that one, and then the bottom one, they all start with 10. Why? Because that's the perpendicular height,
Okay.
which is the same here and also the same here.
Okay.
Does it make sense?
Yeah.
Because they're all the same, that's why you only need to times by the other side, which is part of the triangle.
Okay.
Okay? Alright, and that's why they all start with the perpendicular height. Just remember that, right, for triangular prism. Okay. Alright, so that's question 6. How do you convert these units to centimeters squared? What did you learn at school?
Oh, it's just I don't know, they just told us like how to do it.
Like how? Explain.
We just did it. I don't know.
I'll tell you my technique. Try to understand it and then see if you can explain it to someone else, okay? Because you have to be able to explain it, otherwise it means that you haven't mastered it.
Okay.
Okay? Now, the first step is when you want to convert, okay, I like to write it this way with the arrow there. Okay? And you're converting it into centimeters squared. Right? When you're converting from meter squared to centimeter squared, do you so first you think from meter to centimeter, is it times or divide? Times, right? Because 1 meter has 100 centimeters, right? Does it make sense?
Yeah.
So the ratio is 100. But because you're doing squared, you also square the ratio.
Okay.
Does it make sense?
No.
No. So put it this way. If it's 3 meters, it will be 300 centimeters, right?
Yeah.
Yeah. But then if you're talking about like an area, let's say that's 3 meter and this is also 3 meter, right? Then the area would be 9 meters squared, right?
Yeah.
But because this is 300 centimeter and this is 300 centimeter, what's the total area as in centimeters? It will be
9,000.
No,
90,000.
90,000 centimeters squared. You see how many zeros are there? 4. And that's just because it's like 2 dimensions multiply each other.
Okay.
Does it make sense? So that's why the trick is first you find the ratio from meter, right? So from meter to centimeter is times by 100, right?
Yeah.
But because you are working with area, so meter squared to centimeter squared, that means you also need to square the ratio.
Okay.
Does it make sense now?
Yeah.
Right? Because you're timesing two dimensions together, right? So the number of zeros is double.
Okay.
Okay? So then times 100 squared, that will be 3.5 times 10,000, right? Basically 1, 2, 3, 4 zeros.
Yeah.
So you move the decimal place 4 times to the
to the right.
to the right, correct? The answer will be
3,500. There's 350, right? Well, isn't it supposed to be 350?
it's 35,000.
But if it was like not squared, it would be 350.
Yes, but this is squared, right? So similarly, you see this one? Similarly, if this is 3.5 meter, right?
Yeah.
And this is 3.5, right?
Yeah.
So when you multiply it, it will be like 3.5 by, let's say, 1 meter. Okay? So then that would be 3.5 meters, square meters.
Yeah.
Right? If you convert this one to centimeters, that would be 350 centimeters, but this is 100 centimeter.
Yeah.
So when you times these ones together, it will be
35,000.
35,000, yes, centimeters squared. Right. Does it make sense?
Yeah.
Okay? And that's why the trick is to get the ratio and then you square it. If you're working with areas and you cube it if you get volumes. I think you do that in year 9. Okay, so this is the best technique, okay, that I have developed over the years. It's just because you can remember the ratio between meter and centimeter.
Yeah.
Just remember you're dealing with areas, you square it, all right, because you're working with meter squared. All right, I'll show you another example here. Question B. 7,200 millimeters squared. Now convert from millimeter squared to centimeter squared times or divide.
Or divide.
You divide, right? By what's the ratio between millimeters and centimeter?
It's 1,000.
No.
100.
No.
Oh yeah, 10.
10. Because 10 millimeters. Okay, so 10 millimeters is 1 centimeters, right?
Yeah.
Yeah. So if you want to get the ratio, you can just write the equivalent and then you write, okay, from 10 to 1, you divide by 10. Make sense? But again, we're dealing with squared, so you have to also square the ratio.
Okay.
Okay?
Yeah.
So then the answer would be 7,200 divided by 10 squared, which is 100, and that would be 72. So that'll be 72 centimeters squared. Make sense?
Yeah.
Is this the same as what you learned at school?
No, we didn't do squared.
Oh, okay. They just tell you the ratio, what the ratio is, but I prefer to write it this way. So it will be easier because you can remember the ratio from millimeters, centimeters, right?
Yeah.
Just remember to have to square it. Because otherwise you have to memorize like a bunch of ratios. It's very hard to memorize it.
Okay.
Okay? Just try it. Trust me, this technique will be very handy when you learn about volumes later.
Okay.
Okay? Because when you're dealing with volumes, you cannot possibly remember divide by a million or divide by like a trillion. It's not worth it. Alright, so let's try again. 4 meters squared. Okay? 2 centimeters squared. What's the ratio from meter to centimeter? Times or divide?
It's times 100.
Times 100. And then you also have to?
Square.
Yeah. So then the answer is?
Hold up.
It's 4 and how many zeros? Just gotta tell me how many zeros.
400.
It's 4 and how many zeros?
No, wait, hold up. 3?
No. It's 4 zeros. Why? Because if you're doing 4 times by 100 squared, 100 is 2 zeros. When you square that, you get 4 zeros, right?
Yeah.
Yeah, and it will be just 4 times by 1 and 4 zeros, which is 4 and 4 zeros.
Okay.
Does it make sense?
Yeah.
It's like 4 times by 10 to the power 6. Have you seen this before?
No.
No? 10 to the power 6 just means 10 times 10 times 10 times 10 times 10. 6 times.
Yeah, I've seen powers before.
Yeah, right? So this would be 4. 10 power 6 is how many zeros?
This 6.
It's 6 zeros, yes. And when you times it by 4, it's 4 and then 6 zeros. Once you've got the 6 zeros in, you can see that's 4 million.
So how's 100 squared 4 zeros?
100 squared would be 100 times by 100.
Oh.
Right? So it would be 2 zeros times 2. which is 4 zeros.
Okay.
Does it make sense?
Yeah.
Yeah, so you count how many zeros there are in the main number and then you square that, so you just double the number of zeros.
Okay.
Okay?
Yeah.
Alright, question D. 67,000 millimeters squared to, let's see, 67,000, right?
Yeah.
Yep, millimeter squared to centimeter squared. Do it in your head. Tell me what the answer is. Times or divide, and times or divide by how much?
Divide. By 10. Squared.
Mm-hmm.
So wait, hold up. So divide by 1,000, right?
No, 10 squared is 1 and 2 zeros.
100. 100.
Mm-hmm.
Okay. So that's 670.
Yep, that's right. It is 670 centimeters squared. Make sense?
Yeah.
Yeah? What do you think about this technique?
It's good.
It's good? Understand?
Yeah.
Okay, cool. Remember, when you redo these questions, you can't look at the answer.
Okay.
Okay, try to redo it by yourself first. Now, next is question 8. 450,000 hectares. What's the ratio from hectares to meters squared? Do you know?
No, we don't know. We didn't do hectares.
Oh, did you?
No, we didn't do it.
Okay. Well, I'll just tell you, just in case. It's quite simple. One hectares is 10,000 square meters.
So that okay.
Okay. So 450. So question A, 450,000 hectares. Right. That would be times by
10,000.
10,000. Yeah. 2 meters squared. That would be 4, 5, and then 3 zeros plus 4 zeros is 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that would be 450 million square meters.
Yep.
Okay, but to convert it to square kilometers, we need to start with the square meter version. I prefer to just go to square meters first, so that would be meter squared, right? And then to convert to kilometer squared, what's the technique here?
Kilometer squared is just
So remember, times or divide.
that's divide.
Divide, yes. By how much? What's the ratio?
100. 1,000.
1,000, because 1 kilometer is 1,000 meter, and then
Just remove 4 zeros.
Not yet.
3 zeros.
not yet.
Squared.
Yes, that's right. And then you remove how many zeros?
You remove 5. 4.
How'd you get 4?
Because 1,000 times. Wait, no. 1,000 times 1,000.
Mm-hmm.
6 zeros.
6 zeros. So the answer is.
That's 450 kilometers.
That's right, 450 kilometers squared. Make sense?
Yeah.
Pretty simple, right?
Yeah.
The only new thing that you need to remember is 1 hectare is the same as 10,000 square meter. That's it.
Okay.
Or think of it as 1 hectare is like 100 meter by 100 meter.
Okay.
Okay, so 10,000. Okay, all right. This one here. How many liters does a cylinder? Let's see. Did you learn about liters and centimeters cube?
No.
You sure?
Yeah, we didn't do it like this.
Okay. All right. So I'll skip this one. Okay. Skip question 9.
Okay.
Skip liters. All right. Then we get to this one. Question 11. Did you do times?
Yeah, we did.
Yeah. So like time subtraction and stuff.
No.
Hmm.
No, the teacher just told us she was like, I don't want to go through this. So just does everybody know the difference between 24 hours time?
Yeah. So they will ask you it. Okay. They will ask you, and assuming that you guys know what to do.
Yeah.
So I'll go through it. Okay. 12 noon and 7:45 p.m. Now I'll show you the technique to do some of the harder ones. What's 12 noon and 7:45 p.m.? How many days, hours, and minutes?
7 hours 45 minutes.
Yeah, that's easy, right? Okay. How about question B?
That's 10 hours 30 minutes.
Yeah, easy. Question C?
15 and that's 5 hours. No, 7 hours and 30 minutes.
No.
No, 7 hours 15 minutes.
Yeah, that's right. D. Alright, what's the technique your teacher told you? Did your teacher tell you to write it in this form?
She said she just went through 24-hour time.
Yeah, 24-hour time, which is right in this form.
Yeah.
Okay, so I'll show you starting from question D then. 20 past 7 in the morning, so that'll be 07:20.
That's just 7:20.
Right?
Yeah.
Yeah, and then 5:30 in the afternoon. Now 5 o'clock in the afternoon is how much?
That's 05:30, right?
No, in 24-hour time.
Oh, 17:30.
17:30. Okay?
Yeah.
Yeah, and you need to do the subtraction. Alright, so 17:30 subtract 7:20. Alright, so that would be 10 hours and 10 minutes.
Okay.
Okay, easy? Question E. Now, this is a bit different. From Tuesday to Wednesday. Okay?
Yeah.
So you need to go from 2:35 on Tuesday to 00, right? 00 on the morning of the Wednesday.
Yeah.
And then from 00 to 7:35 a.m. on Wednesday.
Yeah.
Yeah, or 07:35. Okay. Okay, make sense?
Yeah.
Yeah. So from this to this, what's the how many hours from here to here?
From 2 to 0.
No, from this one here.
Oh, 7 hours 35 minutes.
Yeah, that's easy, right? The reason why I'm doing this one first is because it's easy. Now, how do we do this one?
It's 21 hours 25 minutes.
21 hours, 25 minutes. Good. So 21 hours, 25 minutes. So combine them, what would that be?
28 hours. No, just 29 hours. No, yeah, 29 hours exactly.
Which is?
0 to 9.
No.
Wait, what is it?
They ask in days, hours, and minutes.
Oh, okay. So that's just 1 day, 4 hours. Yeah, 1 day, 5 hours.
5 hours. Okay. Make sense?
Yeah.
Yeah. Next is, I'll go through all of these because they get harder and harder. Question F, 2:36 a.m. on Friday and 2:51 p.m. on the following Sunday. So once again, 2:36 a.m. is 02:36,
Yeah.
right? And then we need to go to Saturday morning, and then you go to 2:51 p.m.
No, isn't it 0:00 again on Sunday?
Friday on Friday and on the following Sunday. Wait, they mean? Oh, hang on. On Tuesday and Saturday on next Wednesday. Next Wednesday should be the day after, right? Okay, let me check. Let me check the terminology that they're using here. Oh yeah, 1 day 5 hours. Yeah, okay. Following Sunday.
No, next Wednesday is the Wednesday.
Right after Tuesday.
No, it's the Wednesday that comes back. This Wednesday is the Wednesday that's tomorrow.
I know, but in the textbook, when they said next Wednesday, it's like Tuesday, Wednesday. Right? They're saying 2:35 here, and they're asking 7:35 a.m. That's
Okay.
next Wednesday because the answer is correct. Is 5 hours, 1 day and 5
So
hours.
what about following Sunday?
Following Sunday, they also mean the same thing.
Okay.
Yeah, it just means like the upcoming Sunday.
Okay.
Yeah, so we'll use that notation for now. So that'll be the upcoming Sunday. So Friday, that will be Saturday, and then you have to go to Sunday, right?
Yeah.
And then you go to what's 2:51 in 24-hour time?
14:51.
14:51. That's right, 14:51. Okay, and then from here to here, that's 1 day.
Yeah.
Right. From here to here, what's the easier way to do this?
That's just 22 hours, right?
Not quite.
22 hours, 14 minutes.
Not quite.
What do you mean?
Okay. So I'll show you how to do this one here. It's not 22 hours because when you add to that, it's 24 hours, 36 minutes. Doesn't make sense. All right. The trick is you instead of using 0000, you do 2400 minus 0236. Make sense?
Yeah.
Yeah. But you can't subtract this part here. So you have to borrow 1 from here. So that becomes 23, right?
Yeah.
And then this one would be 60.
Okay.
All right. And you do 60 minus 36 is 24. And 23 minus 2 is 21.
Okay.
Hours, 24 minutes.
Okay.
Does that make sense?
Yeah.
Yeah, make sure you practice this one, yeah? That's the easiest way. You write 2400 and then subtract, right, to find how many days, hours to the next day. And then after that, finding from here to here, that's also easy. That's just 14 hours and then 51 minutes, right?
Yeah.
Okay, so combining these two, that would be 35 hours and 76 minutes. Okay, let's convert this onto how many days and how many minutes. And remember, we still have 1 day between Saturday and Sunday to add on to that.
Yeah.
Okay, so 35 hours, 76 minutes is?
Plus 24 hours.
Yep.
Oh,
So just this one though, let's just work out this one here. So say this would be 1 day, how many hours?
should we do it all at the end?
Yeah, I guess you can add these two together, right? So plus these two, right, would be 1 day,
1 day and
35 hours and 76 minutes, and let's convert it to the standard form.
yeah, so 1 day, no, 2 days, and 11 hours. 76. No, that's another hour. 12 hours, 16 minutes.
12 hours, 16 minutes. 2 days, 12 hours and 16 minutes. Wait, what? The answer is 12 hours and 15 minutes. Oh, sorry. Oh yeah, my bad. What did I write? 235. 6 is 235. Sorry. It's 235, so that would be 25 minutes. Yep, my bad. So that would be what's the other one? Oh wait, 236 and 251.
Yeah.
Oh yeah. No, that's right. Yeah, 236. Yeah, so that would be 24 and then 51. Oh yeah, sorry. It is 75. Yeah. Don't know why I wrote 76. Okay, so 75 minutes, and that's why the answer would be 15 at the end. There you go. That's right. Okay. Make sense?
Yeah.
Yeah. So this technique is not the easiest one to use. It's not like, I think this technique is not easy to remember, but if you once you understand it, I think it's second nature. It's pretty easy, right? Chop it to the midnight and then midnight, and then you can just calculate only the 2 parts. Okay. So the only thing that's new here is how to calculate the time from a certain time of the day to midnight. Okay. So the trick is to use 2400 and minus. Okay?
Yeah.
That's a trick to this one. So go back and see if you can work out question G here. Same idea. Right? Okay. Not too hard. Same idea. Okay. All right. Now let's move on to challenge questions. Okay. Hopefully we can cover all of these. All right. Okay, let's start the challenge questions. Remember, what do you need to do later at home?
Challenge.
Hey?
Challenge and do back the reviews.
Yes. So whatever we do in these notes, I'll send them over, and I'll send a summary in Discord so we can just do those questions. Yeah. Okay. And if you can't do them, then look at the notes or watch a recording. I'll send both the recording and the notes after the lesson.
Okay.
Okay. All right. The areas of the 3 faces are 10, 14, and 35. Find the volume. How do we find the volume?
3 faces. What do you mean 3 faces or rectangular prism?
Rectangular prism means it's one of these things, right?
Yeah.
Right. They're saying the 3 faces are, so this is 10, and this is 14, and then this is 35 centimeters.
Oh, okay. Okay. So find the volume.
Mm-hmm.
So the square would be square would be 3.5.
No. They have to be able to identify what are these dimensions. What's the length, width, and the height?
Yeah. What do you mean?
You have to do a bit of reasoning. Okay. This side is 10, area is 10, and that will be x times h, right? So 10 is 2 by 5, right? Let's say if I take this side to be 5 and this side to be 2. If this side is 5, then y doesn't look very nice, right? It will be like 14 over 5.
Yeah.
Okay, so it doesn't really work. So
it's 2 and the other one will be 7.
Yes, that's right. It will be 2, 5, and then this one will be 7. Does it make sense now? It will be 2, 7, 5.
Yeah.
Okay, and then you have to calculate the volume.
Yeah.
Make sense?
Yeah.
Alright, so pretty easy, but if you don't know how to do it, you can't even get started. Question 2. Cylindrical container. Okay, so this is a cylindrical container questions. Diameter 80 and height h is filled with water. How many cylinders of diameters 20 and height h would you need to hold the same amount of water? What do you need to do here? What are the steps here?
Find the circumference of the cylinder.
No, find volume, because how much water, right, is the volume. Okay, find volume of both cylinders. Of both cylinders. And then
there's only one cylinder.
There are two. The first one is diameter 80 and height h.
This is how many cylinders of diameter 20?
20 and height h.
Wait, that's not 2 cylinders though.
Well, they're saying that this one, okay, so one cylinder is diameter 80, so that's a big one, right? So that's 80 by h. Okay, that's 80 by h. Yeah. And then they're saying how many of the smaller one, which is like your 20 by the h, would you need to hold the same amount of water? Does it make sense?
Yeah.
It's like you have a bigger cup and then you pour into a bunch of smaller cups. How many smaller cups you need?
Yeah.
Alright, so that's what I meant by both cylinders.
Yeah.
Because you need the volume of the big one, volume big, and then you divide by volume of the small one in order to get how many of the small cylinders.
Yeah. Okay.
Make sense?
Yeah.
Yeah. So then divides, and then after that you just divide them. Alright? So in this case, the volume of the big cylinder would be what?
Pi times 80, times 40,
40 squared times h.
Okay.
Okay? And then volume of the small cylinder would be?
You can't do it with the radius, can you? You can't find volume with the radius.
You
can't find volume with the diameter.
No, you can't. You have to divide the radius first.
Okay.
Okay? So that'll be 10 squared times h, make sense?
Yeah.
Yeah. And then this one would be what? 1600 pi h, right? And this one would be 160 pi h, and this would be 100 pi h.
Yeah.
Alright?
Yeah.
Make sense? Yeah. And how many cylinders of diameter 20 and height h would you need to hold the same amount of water? So you take the volume of the big one, divided, hang on, 40, that's 1600. Yeah, that's 1600, because there'll be 2 zeros here. That'll be 40 by 40. So there'll be 2 zeros and 16. Okay, so volume big divided by the volume of the small one, right, would be 1600 pi h divided by 100 pi h. Right, pi h will cancel out. The 100 cancels out the 2 zeros, so the answer will be 16. So you need 16 of the smaller ones to hold the same amount of water.
Yeah.
Make sense?
Yeah.
Okay, moving on. Again, remember, when you redo these, you have to try to remember how much, whatever I have said, and try to do it again yourself, yeah?
Yeah.
You have to do all of these questions.
Yeah.
That's a bare minimum to be able to attempt some of the harder ones in your exam. Now this one here. Find the surface area of the object. In the interest of time, I might have to just keep going through the explanation. Look top down. The trick is look top down. What would it look like top down?
What do you mean?
So imagine if your eye is on the top, right?
Oh yeah, okay.
Right, and then you look down from here.
Okay.
It looks like a
bird's eye view.
Yeah, it's a bird's eye view, and that will look like a square.
Yeah.
With a bunch of others, with 2 smaller squares like that.
Yeah.
That makes sense?
Yeah.
So what do you think is the area I get if I add this one, and then this area, and then this area? It becomes? it becomes
What?
the area of the bottom cube.
What do you mean?
Right?
Oh, yeah. Okay.
Does that make sense? Because, like, if I were to draw this one in blue, it would just be this blue area, right?
Yeah.
And then I draw this one in gray instead, then it would just be this gray area here. Right?
Yeah.
So you see, when you add all of the areas up, it will simply be the whole square of the bottom.
Yeah.
Right? Which means you can cheat a little bit. So the surface area would be, instead of having to do like the blue one minus the red one and then plus the red one, it's the same thing. So that would just be the top surfaces, right, plus the sides, all the sides, plus the bottom of the large one, of the 3 centimeters one, right? Because the other two bottoms, you can't see them.
Okay.
Does that make sense?
Yeah.
And then the top is essentially, again, I already showed you the top is just the area of the surface of the bottom cube. So it'll just be 3 by 3. Okay. And then the sides, now the sides is a little bit tricky. The top one is 1 by 1 and there are 4 sides.
Yeah.
Right. Then the second one is 2 by 2 and there are also 4 sides around. Right. And then you have your 3 by 3 and then 4 sides. And then you have the bottom, which is another 3 by 3.
Yeah.
Make sense? Add them all up, you get your total surface area.
Is the bottom like the one underneath the big cube?
Yeah, that's right. It's this one here. Is the bottom.
So why don't you do the bottom of the other cubes?
Sorry?
Why don't you do the bottom?
Because you can't see them.
Okay.
Right? Like the top cube is sitting on the next one, so you can't see that. So it's not counted as part of the surface area.
Okay.
It's hidden. You can't see it.
Okay.
Because put it this way, surface area is like if you take a paintbrush, if it's a surface area, you have to paint it.
Okay.
Right? But if it's squished like that, you can't paint it.
Yep.
So it's not part of surface area.
Okay.
Okay? So that's question 3 there. Yeah, it requires that little bit of intuition to like see from the top down. Otherwise, your calculation will be a bit painful. Question 4. All right. A square piece of card has area 49 centimeters squared. Squares of side length 1 are cut from a corner and find the volume of the open box. Okay, turn up the flaps and gluing. This is 1. This is 1. So what's this side here? The one I just drew.
Well, hold up. Where?
The one I just drew. The line I just drew. Because when you fold it, this is the fold line, right?
Yeah.
That's a fold line, right?
Yeah.
Yeah, what's the length of the fold line?
So that's 47.
Very good, 47. So what's the total volume?
No. Isn't it 7? Because the area is 49.
Oh, yeah. So that'll be 5.
Oh, yeah. Okay.
Yeah?
Yeah.
Okay. So yeah, so that's right. This is 7 and then this is also 7. And therefore you have to subtract 1. So that one is 5.
Okay.
So the thing is not to scale.
Okay.
Okay. So volume is 5 by 5 by?
By 5.
By another 5?
Wait, so... No, by 7.
Not by 7.
Volume of the open box formed by...
What's the height?
It's 7. 1.
It is 1.
Why is it 1?
You cut the square of length 1.
Yeah.
Right?
Oh, okay.
So the part that you fold up is the one that was cut out.
Okay.
The 1 centimeters, right? And the 5 is only the base.
Okay.
That make sense?
Yeah.
Yeah? So you're joining these two parts together, it becomes a height. Right? Same with these one. Join these two together.
Okay.
Right? So it's 5 by 5 by 1. To visualize, it looks something like this. Okay? So this is 1 after you turn it up, and then the bottom is 5 by 5.
Okay.
Okay? So that's why. Can't mess that one up either. Now, this one is getting a little bit harder now. You have to start applying the knowledge from the previous questions in order to do these ones here. X, Y, Z are the midpoints of the edges they lie on. Triangular prism is formed by cutting through the point X, Y, and Z. Find the volume of the remaining solid. What's the main idea here?
Cutting a piece of the rectangle prism, triangle prism.
Yeah.
Oh, okay, so you find the big one, and then you find the small one, you minus.
Yes, you can do that. You can do that.
Okay, so 6 times 8 times 20 times 6.
8 times 20 times 6. Yeah. Okay. And then, how do we get the volume of the smaller one? What shape is it?
Triangle.
Yeah.
Triangle prism. So
do we know this side?
no.
Can we find that out?
Midpoints on the edge they lie on. So 8.
Not 8. Midpoint.
So mid, so there's 4.
4. Yes. This side is 4. How about this one?
That is also 4.
No.
So, no, it's 3.
It's 3. Yes. So what's the volume of the small triangular prism?
Small. That's 4. 12. No, it's 4 times 3 times 20. Yeah.
Not all. What's the area of a triangle?
Times half.
Yes. Half base times height. Okay. That's the volume of the triangle.
Okay.
Yeah?
Yeah.
Okay, good. So you got the idea that you need to get the surface area, which is a triangle, and then you times it by the perpendicular height.
Okay.
Alright, so work that out and you get the answer. Make sense?
Yeah.
Okay, cool. Make sure you go back and practice these ones. Next is question 6. A cube with edge length 6 is made from cubes with edge length 1. This one is getting a bit trickier. The 1 centimeters cubes making up the larger cubes and then rearranged to form 2 rectangular prisms. The base of one rectangular prism is 8 by 5 and the base of the other is 6 by 4. What is the height of each rectangular prism? Okay. How do we solve this one? I'll help you out. A cube with edge length 6. Again, when you get these kind of questions, you have to draw the map. Do you know how to draw a cube?
Yeah.
Yeah, so make sure you are able to draw a cube. So the trick to draw a cube is this. Any diagonal lines are parallel to each other, and vertical lines must be vertical. So you see these two are vertical.
Yeah.
Right? And then any horizontal line are horizontal. So this one is horizontal and parallel with this and parallel with the top one.
Yeah.
Yeah. And then similarly, this diagonal one has to be parallel with the other diagonal one.
Okay.
Right? So that's a trick to draw a nice looking cube. Alright, so that'll be 6 by 6 by 6. Okay, and then the cubes making of a larger cube then rearrange to form 2 rectangular prisms. The base of one is 8 by 5, so let's redraw that into an 8 by 5 rectangular prism. That's 5 by 8 here, and then the other one is 6 by 4. The other one is 6 by 4.
Okay.
Okay, what is the height? Making a larger cube rearrange to form 2 rectangular prisms. The base of one is 8 by 5 and the base of the other is 6 by 4. Yep. Now what is the height of each rectangular prism? So they're saying that if you draw a rectangular prism here, right, what is the height of this one? And similarly, what's the height of this one? They're not the same. Right, what's the height of these 2 rectangular prisms?
Hold up. So
this is a tough one. What must be the same?
The height.
What is the same between these two rectangular prisms and the initial cube?
They both have.
Because this one is made up of like smaller ones, right? And they chop it up and they use a smaller cube, which is 1 by 1. So the idea is that they use a 1 by 1 cubes here.
Yeah.
Okay, to rearrange, right?
Okay.
Yeah?
Yeah.
So what has to be the same? When you move, like when you break a shape and form different shapes, what is still the same?
They all have 1 by 1 cubes.
Yes, the 1 by 1 cubes must be the same, which means the volumes are the same. Right? Volume of the 6 by 6 by 6 must be the same as volume of the rectangular prism 1 plus the volume of the rectangular prism 2. Does it make sense?
Yeah.
Yeah?
Yeah.
Because all the cubes, they don't go away, right? It's still there. So the volume must be the same.
Yeah.
Alright? So the volume of a 6 by 6 by 6 is 36 times 6, that's 216.
Yeah.
What's the volume of the rectangular prism 1? It's 40 times h1, right?
Yeah.
This is base times height, yeah? Area to base times height.
Yeah.
Plus, what's the volume of the second one? It's 24 times h2. Now, how do we find h1 and h2 here?
They're from the volume.
Sorry?
They're from the volume.
Yes, but the restriction is they must add to 216. So the technique is trial and error.
Okay.
You just have to trial and error to work this one out. Okay? And to trial and error more systematically, you need to write a table. h1 and h2.
Okay.
If h1 is 1, what must h2 be?
It'll be 216.
Sorry?
216.
No. If h1 equals to 1, then you would get to calculate h2, 216 equals 40 times h1, which is 1, plus 24 times h2.
Okay.
Right?
Yeah.
Yeah? So 216 is equals to 40 plus 24 h2. Right? Then you minus 40 from 216, that will be 176 equals to 24 h2. Well, can you get a nice answer for h2? 176 divided by 24 is?
4. Hold up. Now.
You can simplify it, right? You divide both top bottom by 2. So that would be 88 over 12. Make sense?
Yeah.
Alright, and divide by 2 again, that's 44 over 6. That's 22 over 3. Does that work?
Yeah.
No.
Why?
What's the restriction for H2? This is formed by
1 by 1.
Yeah. So can you get a point something
No.
height? No, you can't. So in this question, you're basically trying to find a H2, find a pair of H1 and H2 that would be whole numbers.
Okay.
Does it make sense?
Yeah.
Yeah. So now we have to try again. H1 equals 2.
Yeah.
Alright. Then H2 would be 216 equals to 80 plus 24 H2, right?
Yeah.
Okay. So minus 80 would be 136 equals to 24 H2. Can we get a nice number from here?
Hold up. 6 over 24. Yes.
Yeah. What times, 24 gets you 136. What whole number?
8.
No. 8 times 2 is 16. 9 times 2 is also
6.
6 times 2 is 12. 6 times 4 is 24. Not ending in 6. Alright, I'll show you another technique. So once you've got to this version here, you see how we're working with 2, 16, 40, and 24. It's a bit hard to work with.
Yeah.
Alright. You can divide every number by 2 to get an equivalent expression.
Okay.
Alright, it will help with the trial and error. So let's see what happens. Let's see what happens when you divide them all by 2 here. So the equivalent, 216 divided by 2 is?
108.
Yes, 108. And then that would be 20, right? Plus 12 H2. Can we simplify further?
Yeah.
Yeah, by?
You can go by 4 again.
By 4 again. Very good. Divide by 4. Okay. So then you would get?
You'll get 27. So,
Yep.
Yeah, okay. And then 5 and 3.
Okay, now we can guess H1 and H2 is a lot easier, right?
Yeah.
So let's try H1. Okay, so I'll rub this one out here because this is a bit too hard to work with. Okay, so let's try H1, H2, and then we'll calculate what is 5H1 plus 3H2. So if H1 is 1, H2 is 1, then you would get 5 plus 3, which is 8. That's not close to 27 at all, right? Yeah. So let's try a few. 2H1 and let's say 2H2. That would make it a little bit closer. That would be 10 plus 6, which is 16. Getting a little bit closer.
Yeah.
Okay. So 3 and 3 would be 3 times 5 is 15. 3 times 3 is 9. So that's 24. Oh, pretty close. What do you think is the final pair then?
Is it... Wait.
So far, 3H1 and 3, if H1 is 3 and H2 is 3, you get 24. We want 27.
4.
For what? What are the two numbers? What's H1?
Hold up.
We need 3 more. How do we get 3 more?
4. You can do 4 for the first one.
4 for the first one, and then?
Actually, no, you can't do 4. Do 5.
That'll be 25.
Yeah. And then...
The other one is 3 times H2. Must be...
You can't do.
No. Remember, from 24 to 27, you need just 3 more.
Do 3.
Sorry?
3.
3 for the H1 and?
And then... Wait,
Okay, wait. Pause. So far we've got...
Hold on, I think I got it. Do it again. 3. And then... That's 4.
3 and 4, yes. So that'll be 15 plus 12, which is 27. That's correct. Now the easier way to see this is this. From 24 to 27, you need how many more? 3 more.
Yeah.
Right? And see, it's 3 times H2. So if you increase H2 by 1, the sum will increase by 3.
Okay.
Does that make sense?
Yeah.
So that's why you increase the number 3 by 1 into 4. And so the final answer is the height would be 3 and 4.
Okay.
Make sense?
Yeah.
So this is a technique to do trial and error. But remember, you need to be able to form the idea that the volumes of the big one must be the same as the other 2 volumes. Right? And then get the equation, and then you need to simplify. Okay? You need to simplify the equations in order to work this through.
Okay.
So the thing is, these questions, right, if you give it to a higher grade, they might also struggle as well, because the technique actually combines a lot of different things.
Yeah.
Okay? But does it make sense?
Yeah.
Do you think you can do this again at home?
No.
No? Okay. If you need to, watch the recording again when you try it out.
Okay.
Right? But you have to be able to get to the point where you put everything aside, you look at just the question 6, and then you do the whole thing. Okay? So these are the problem solving questions that QA would be expecting you to be able to do.
Okay.
Okay? Okay. We'll skip the... Actually... Okay, this one. We'll go to this one. It's actually quite simple. I won't even have to have that in the notes. So prisms whose bases are horizontal but the sides are not vertical are called oblique prisms. This is called a parallelly. I can't remember how to pronounce it. Parallel pipette or something. Parallelly pipette. Yeah, something like that.
Okay.
Parallel pipette or something. Anyway, so this one, the volume is the same. It's area of the base times the perpendicular height.
Yeah.
Right. So in this question here, the base is just a rectangle 4x3, and the perpendicular height is 5. So the volume of the parallel pipette on the side is just 3/4 times by perpendicular height, which is 5.
Yeah.
Easy. Right. This one will be the same thing again. It will just be base times height.
So it's just the parallelogram, but like opposite.
Sorry?
It's just a parallelogram but opposite.
Not well. Yes, yes.
Okay.
Well, that's the general idea. Yeah. So you're right. Think of it as having a parallelogram here, right?
Yeah.
And then you extrude it in the other direction.
Yeah.
Yeah. So you still take the face of the parallelogram, which is the perpendicular height, times by the base here, and then you times by the other, like perpendicular, the other height.
Yeah.
Right. That's the height of the prism.
Okay.
Okay. So same idea.
Okay.
Okay. So that one is fine. Hopefully that question comes out because then you will be able to do it easily. All right, this one. A cube of side length 3 is made from 27 cubes of side length 1. 3 cubes are removed, so there's a hole from one face to the opposite face. What is the surface area of the resulting object?
Okay.
How do we draw this?
A cube of side length 3, so just
Draw a cube, right?
yeah. Yeah.
Okay, and then?
Cube of side length 3, so the sides are 3, right?
Yeah, 3 by 3, yes.
Okay, and 27 cubes with sides of length 1 centimeter. So it's just cubes, but 1 by 1 cube, right? 27 of those.
Yeah, 27 rows, yes. 3 cubes are removed so that there is a hole from one face to the opposite face. How would we represent that in here?
Put a hole in the middle.
Yep, hole in the middle. Okay, and then draw. Have you seen this before? You draw the dotted line down to show that it goes all the way to the other side, like this. Have you seen this?
No.
Hey?
No.
No, but imagine it's a hole, right? So the dotted line means you can't see those lines, but it goes from one side all the way to the other.
Okay.
Okay, how do we find the surface area?
Well, the cubes are 1 by 1, right?
Yep.
So we find the surface area and then minus by the smallest one.
Yep, okay. So the total surface area of a cube minus what?
Minus the small surface area.
Which is?
1 by 1.
1 by 1, yep.
Times 3.
Times by?
3.
Not 3. Times by 2.
How many? No, it's 3 cubes are removed.
Yeah, but normally the only two surfaces that are affected is the top one and the bottom one.
Okay.
Right?
Okay.
Does that make sense?
Yeah.
But the 4 sides are not affected.
Okay.
Right? So only the top and the bottom. So the top and bottom will be affected by the removal thing here. Okay? So that will be the total surface area minus, like that tiny area and 2 of those. What else? That's not all. You need to plus something. Plus what?
Plus.
What have we not accounted for? Now that we have a hole coming through it.
The other sides? No, the amount of cubes.
No. The inner part of the hole. Does it make sense? The inner part of the hole is this area here.
Oh, yeah.
And there are 4 of those.
Okay.
Alright?
Yeah.
Because you can see it. Right? When you look inside, you can see those surface.
Yeah.
So it's also counted as surface area.
Okay.
Okay? So total surface area would be 3 by 3 by 3 minus 1 by 1 by 2, which is 2, plus what's the inner part of the hole? It's just 1 by 3, and then how many are there? There are 4 of those.
Okay.
Okay? So we quickly work that out. 27 minus 2 plus 12. So that'll be 25 plus 12. That is 37. Okay? And then you got to write centimeters squared.
What? 27 minus?
2 and then plus 12.
27 minus... Oh. It's 2. Oh, yeah. Okay.
Okay, make sense?
Okay, isn't it 27 minus 14 though?
No, you have to minus 2 first before you plus 12.
Okay.
When you have plus and minuses, you have to do left to right. Yeah? Because if you add these 2 first, then that would be technically like that, which is not right.
Okay.
That would be 27 minus 2 minus another 12.
Okay.
right? But it's minus 2, and then you have to add the inner part of the hole on top of whatever you've got for the outside, which is 37. Double check. 3 by 1, 4 of those. The unique answer is 64, which is double of what I've got. Sorry, silly me. All right, the total surface area would be one face and then times it by 6, my bad. Yeah, what I did was the volume.
Oh, okay.
All right, so it will be one face, which is 3 by 3, so that says that's height there.
And the bottom one, right?
Well, yeah, so it will be 6 of those, but then 2 of the faces are affected by this thing.
Okay.
Yeah, so that will be 9 by 6 is 54.
Okay.
Yeah, so minus 2 plus 12 is 64. Yeah, there you go. That's better. Yeah.
Okay.
Okay, make sense?
Yeah.
All right, please go back, try that one. Last question. We can actually finish everything in the challenge exercises today. But note that this is a bit rushed, yeah? Normally I would want to give you some time to practice these in class first. But today is a bit rushed, so I have to rely on you to actually go back and redo these questions, yeah?
Okay.
So it's all of the review and all of the challenge, except for the liters one.
Okay.
If you didn't learn liters, then ignore the liters ones. I'll send you the list of questions later after the lesson. How many solid rectangular prisms of dimension 1 by 2.5 by 1.6 can be cast from 1 cubic meter of steel? How do we do this?
Draw the shape first. Rectangular prism.
Uh-huh.
Isn't it just like 1 cubic meter? Is it just like? It's just like a bar.
Well, it's just saying 1 cubic meter of steel. It can be anything. It can be in a bowl. It can be in like a jar. But if you pour into like molds, each mold is like 1 centimeters by 2.5 centimeters by 1.6 centimeters. How many of those tiny molds can be filled up?
So do you have to find the steel like dimensions first or no?
Yes, you do. You do need to convert something first. Okay, and in this question,
convert the meters to centimeters.
Yes. So 1 cubic meter is how many cubic centimeters?
It's
Again, the technique I said earlier actually applies here.
1 meter is 100 centimeters, right?
Yep. Times or divide by 100. Well, times 100. We're running the answer here, but remember you did cubic.
Cubed.
So
add 3 zeros. That's 10,000.
no. How many zeros?
100.
How many zeros? It's 2 zeros and then times 2 zeros times 2 zeros. All right.
So it's 100,000, right?
It's how many zeros?
It's a million.
It's a million. Yes. 6 zeros, right?
Yeah.
Because it's 2 zeros powered by 3 is 6 zeros, right?
Yeah.
So yes, it's a million centimeters cubed. Correct. So what do we do then?
Then you can't you just divide it straight up?
Yes, you can, but normally you find the volume of the the prism first, right? So that's 1 by 2.5 by 1.6.
Yeah.
Okay, so you can just do this on the side here, 2.5, 1.6. So that would be 3, 15, 25. That would be 400. So looks about right. Yeah, looks about right. 400.
Okay.
But then 2 decimal places, so it'll just be 4.
Okay.
Okay. So the volume is 4 cubic centimeters. So how many can be cast?
Hold up. A million divided by 4, right? 250,000. 250,000.
250,000. Yes, that's right. 250,000. How did you do that?
It's just 250,000.
Yeah, that's a quarter of a million. Yeah. Okay, good. Well, another way of what I was doing was actually taking the first 100 divided by 4, which is 25, and then add back the zeros, which is 4 zeros.
Okay.
Yeah, so it'll be 25 and 4 zeros.
Okay.
Okay, all right. That is it. That's all of chapter 15, review and challenge questions that you need to go through. Okay,
Yeah.
we're able to go through all these today.
Yeah.
Okay.